So, welcome Mark to Krakow.
Thanks very much.
Fantastic weather today.
Fantastic.
Now, people know you play the guitar, but I've also heard that you're a scientist, PhD, and I'm kind of curious as to how that all meshes together. Tell us a bit more about what you're going to do today.
Right, I'm going to explain the science of rock guitar, the physics behind the guitar. I'm a guitarist myself, so I'll be doing a bit of Van Halen and all that. And I basically start with a guitar string. A guitar string is a beautiful mathematical object with lots of different patterns of vibration at different frequencies. So I get a long spring, slinky spring, and I do the different patterns of vibration of the string. Once you understand that, you can get a very good idea of where music comes from. Music and sound in general. It's just shaking the air around at different frequencies. Now in an electric guitar, what you do is you add so much distortion, you kind of squash the waveforms that you get this really rich sound with lots and lots and lots of different frequencies, lots of different harmonics that gives it that kind of really rich kind of chest thumping sound behind it. And then I explain, well, not really explain, just mention that just maybe the physics of guitar strings might apply to the entire universe with something called string theory, in which the tiniest particles that we're made of have something to do with these kind of constrained vibrations.
So when we're listening to a particular song or a particular tune, and we get those goosebumps,
yeah,
is that the sound vibrations, the waves?
That's kind of more psychology than physics, but the richness, the texture of heavy metal or rock guitar, you can explain that with physics. That's like I said, it's about kind of squashing the waveforms. If you think of a nice sine wave, that would sound like it. Very pure kind of curvy sine wave, if you like. Whereas if I squash the waveforms and add lots and lots more harmonics and make it much richer, those kinds of sounds they do sound more interesting, if you like. If you just listen to a sine wave on its own, it's very irritating. The human ear prefers much richer sounds with a lot more information.
Now, where I work, we do have a few teachers who are pretty good on the guitar.
Right.
Everybody knows electric guitars. Will they be able to develop more in the future?
Oh, that's a tricky question. They're very, very well developed now. In fact, I'd say an electric guitar is almost a different instrument to a normal classical guitar. Such are the differences. The possibilities for future development, there's a very interesting one, but not with electric guitars, but with acoustic classical guitars. For a classical guitar to make a sound, the string on its own is very quiet. Sound is about moving the air around. So a thin little wire, a thin little string doesn't do that well. It transfers its vibrations to the wooden plate that moves the air around and makes the string louder. And it does that most effectively if the plate is as stiff as possible but as light as possible, so the string can move it most easily. And if you made a plate out of diamond or graphene, that could make the best guitars ever.
Well, thank you very much indeed. It's fantastic to talk to you, and very much look forward to seeing the show.
Thanks so much. Cheers.